Now again we're going to express the volume of solids generated by rotating some region around the lines y equals y equals c or x equals c when x or c or y are not 0 without the graph. So in the previous video we did the first one, now we're going to do the second one. So we are rotating it around y equals 4, so everything needs to be in terms of x, dx, etc. So the bounds of integration will be, one is the y-axis, so one would be 0. The other bound of integration will be when the graph y equals square x intersects with y equals 4. So when y is equal to 4, x is equal to plus or minus 2. So here we don't know if we want to do it in, let's say, in the left or in the second or first quadrant. Let's say we want to do it in the right quadrant. So I will take the boundaries from 0 to 2 of what's the radius? The radius is the distance between the graph and the line around which we're going to rotate it. Now, how do we know if we subtract this from this or the other way around? Remember, we need to pick a point of, in this case, x, that is between the bounds of integration and see which one is greater. So let's pick 1. So if x is equal to 1, y is equal to 1, this would be greater. So will be 4 minus x squared, this square times pi dy. So we have the radius square times pi is the area times dx times dx gives us the volume of a disk, and taking the integration from 0 to 2 will give us the volume of all that disks. The next one, the region between x equals 1, y equals 2, y equals 4, about x equals 1. Alright, so this is x equals 1, so we have everything in terms of y. So first, let me put our, we don't have any function here. Alright. Let me check for this problem. I think that I forgot to put the function x equals 1, y equals 2. Alright. If don't, I will leave that at the end. Alright. Let me put a mark here. Alright. The next one is y equals 3, x equals pi over 2, y equals 3 cosine x about y equals 3. Alright, everything we need to put it in terms of x because we are rotating it around y equals 3. So the bounds of integration will be 1 is x equals pi over 2. The other is the intersection between y equals 3 and y equals 3 cosine x. So the intersection will be when 3 equals 3 cosine x. So 1 is equals to cosine x. So is when x equals 0. So the bounds of integration will be from 0 to pi over 2 of, let me take out the pi, because remember that is the volume will be the integration from a to b, let's say, of pi r squared d something, dx or dy. So I will put out the pi here. And now what's r squared? R squared is the distance between 3 cosine x and 3. So let's pick a point between 0 and pi over 2 and see which one is greater, 3 or 3 cosine x. So let's pick pi over 4. So pi over 4, cosine of pi over 4 is 1 over square root of 2. So it's 3 over square root of 2. This is the same as, we have 3 over square root of 2 you multiply everything by square root of 2, and so you have 3 square root of 2 over 2. This would be like 1.5 times square root of 2, that is like 1.4. Let me do it. I think that it's less than. Let me do it. I have 1.4 times 1.5 is like 2.1. So 3 is greater than y equals 3 cosine x. So we subtract this from this and then square it. So it's 3 minus 3 cosine x, all this square, dx. The next one, rotating the region around y equals 1, that is enclosed by y equals 1, y equals cubed x, y equals and the y-axis. So again, we need to put everything in terms of x. We will have the volume is pi times one of the bounds of integration are the y-axis is the same as saying x equals 0. The other one is when 1 and x cubed are the same, so it's when x is equal to 1. So 1 and 0 are the bounds, so we go from 0 to 1. Now what's the radius square? Let's pick 0.5. 0.5 cubed is 0.125 compared with 1. We need to subtract this from this. So we have 1 minus cube x, all this square dx. The next one would be the region enclosed by x equals 3, y equals 2, y equals 1 over x minus 1, rotating it about x equals 3. So everything needs to be in terms of y's. So here we can put it as we multiply everything by x minus 1. We would have y times x minus 1 equals 1. We divide everything by y, and then we add 1 to both sides. Then we need to see which function is greater. X equals 1 over y plus 1, or x equals 3. So let's pick our bounds of integration. One is y equals 2, and the other is when this function x equals 1 over y plus 1 intersects with the function x equals 3. So when x is equal to 3, so when x is equal to 3, y is equal to 1/2. So our bounds of integration are, this would be pi times the integration from 0 to, no, sorry, from 1 to 2. Yeah, that's it's correct. And from 1/2 to 2 of the radius is, let's pick something between 2 and 1/2, 1. So x always will be 3 in this case, and here would be 1 over 1 plus 1, 2. X equals 3 is greater than x equals 1 over y plus 1. So the bounds of integration, the radius would be 1 minus 1 over y plus 1, all this square dy. So this is the same as, let me put it here, the pi times the integration from 1/2 to 2 of just minus 1 over y square. So this would be 1 over y to the 4th power dy. Next we have the region enclosed by the equation y equals 2 times x minus 1 all square, y equals 2, rotating it about y equals 2. So everything in terms of x. One of the bounds are, we don't see immediately any bounds, so let's see what are the intersection between y equals 2 and 2 times x minus 1 square. So this would be 2 is equal to 2 times x minus 1 all square. We divide everything by 2 and we got 1. Square root is plus or minus 1 would be equal to x minus 1. So x is equal either to 2 or 0. So the limit of integration would be 0 and 2, that are the points in which these two equations intersect. So pi times the integral from 0 to 2 of what's the radius. Let's pick some x between 0 and 2, let's say 1. Y equals 2 always will be 2, and here we'll have 1 minus 1, 0. So y equals 2 is greater than 2 times x minus 1 squared, so would be 2 minus 2 times x minus 1 minus 2 times x minus 1 square, and all this is square dx. The other one is the region between y equals 1, x equals 4, y equals square root of x plus 1 about y equals 1. So everything again in terms of x. One of the ones of integration are x equals 4. The other one will be when y equals square root of x plus 1 is equal to 1. So it would be 0. So pi times the integration, define integral from 0 to 4 of, let's pick 1 for example. So here will be 1 plus 1, 2, compared to this is greater. So square root of x plus 1 minus 1 is square root of x. Square is just x dx. The next one would be the integration, the region enclosed by y equals square root of x plus 2, x equals minus 2, y equals 1, y equals 3, rotating it about x equals minus 2. So the bounds of integration would be y equals 1 and y equals 3. So we have pi times the integration from y equals 1 to 3 of, now the radius, let's first put this in terms of x, of y. So it's y squared minus 2 is equal to x. So let's pick something between 1 and 3, that's y equals 2. So 4 minus 2 is 2 compared to y equals, compared to x equals minus 2. This is greater, so we subtract this from this. So it's square y, the radius would be square y minus 2 minus minus 2, so plus 2, and we already talked about why it is plus 2 if we are rotating it around some negative value of x. And so we just have y squared, the radius is square y, and we are squaring the radius, so we have y to the 4th power dy. In the next video we're going to do the last 3, or no, it would be very fast if we do it now. Alright, so x equals 4, y equals e to the x, y equals 1 about x minus 4. Here we have everything in terms of y. So here is x equals to the natural logarithm of y. One of the bounds of integration is y equals 1. The other is when x equals 4 and y equals e to the x intersects. So when y is equal to e to the 4. So this is the integration from y equals 1 to e to the 4. Y equals 1 to e to the 4 of, let's pick something between 1 and e to the 4. E, that's e. If y is equal to e, x is equal to 1 compared to x minus 4. So we have natural logarithm of y minus minus 4. So plus 4, all this square, dy and d pi. Actually, we're running out of time. In the next video, we will continue with the other two problems.